you need to sit on your chairs because Walker is going to really wake you up. I've heard a preview of what he says, and he got me revved up. So over to you, Walker.
Thank you. All right, good morning. Well, it's good morning for me, and good afternoon to everyone out there. It'll take me a couple of minutes to get revved up since it's so early in the morning here in Central Standard Time. But my presentation today is on supply chain 4.0, right? What is the future of supply chain in industry? But I'm actually, because the room is more technical than I'm used to presenting to when it comes to supply chain, I'm actually going to start the presentation with some background on Industry 4.0 and digital transformation. Okay. Before I do that, let me start with some cold hard facts. Here in North America, over the course of the next decade, 11 out of 12 manufacturers in North America are legacy manufacturers, so Industry 3.0 manufacturers, are either going to get acquired or go out of business in the next decade. 11 out of 12. And that holds true for all non-subsidized economies in the West. So here in the United States, industry is not subsidized by the federal government. It's not owned by the federal government in any way, shape, or form. And so the market just does what it will. And what it will do in the next decade, very important to note, is that 11 out of 12 manufacturers over the next decade will either go out of business, they'll either file for bankruptcy, or they're going to be acquired. They're going to be replaced by emerging technology, okay, by emerging manufacturers who have followed the Tesla and or Amazon model of manufacturing. Okay. Even if a manufacturer has the market cornered, so they have some federal contract, they are politically connected, they have patents, those companies will be compelled to digitally transform as well, or otherwise their organizations will not plug into the supply chain of the future. So what we're ultimately going to get to in this presentation is, where is supply chain going? That is, how are manufacturers going to plug into the future supply chain? Today's supply chain is very linear. So if I'm a manufacturer and I bring raw materials in the back door and I send WIP or finished goods out the front door, I'm using a linear supply chain to do that. Okay, so I have suppliers who make stuff. I have distributors and wholesalers who I buy that stuff from, sometimes directly from the supplier. I convert that into finished goods, and then I sell it to my customers. I know the customers I'm selling it to because they're in my CRM, and I know the suppliers, distributors, and wholesalers I'm going to be buying my raw materials from because they're in my ERP system. The supply chain of the future is not deterministic. I don't know the suppliers, distributors, and wholesalers I'm going to be buying from. I'm going to be sending my request into an ecosystem, and that ecosystem is going to respond. Today, I know all of the customers that I could potentially sell to in most cases. Tomorrow, I'm going to send my goods into an ecosystem, and consumers, like a moth to a flame, will come to my product no matter what I make. No matter what I make. All right, so let's do some background stuff. Start with, why are Amazon and Tesla so awesome? So let's start with, why is Tesla so awesome? And I'm sure everyone here has opinions on why Tesla is awesome. I'll say this. The reason you think Tesla is awesome is not the reason they're awesome. So does anybody in the room, I think I can see most of the room. Does anybody in the room own a Tesla?
No, there's no Tesla in South Africa, Walker.
Okay. Well, everyone here lives in South Africa?
Yes.
Okay. Here's why a Tesla is amazing. Here's why it's awesome. It gets better after you buy it. So right now, the cars that you guys drive are the same cars you drove off the lot. They're just worth a lot less. They haven't changed in any way, shape, or form. Okay. It doesn't matter that they don't drive themselves. It doesn't matter that they don't have full self-driving. It doesn't matter that they don't have big, huge iPad displays. What the piece that matters is that your car that you drove here today is the exact same car you bought and drove off the lot. It's just worth less and it's beat up more. A Tesla gets better after you buy it. It's not the same car 2 years later. And how does Tesla do that? How does Tesla make cars better after consumers buy them? Well, number one, they're connected to all the cars they've ever sold. 24 hours a day, 7 days a week. Number two, they've built the cars in such a way with instrumentation and sensors on the vehicles so that they can collect measurements off the car that they know they want to collect today. And they have the potential to collect measurements they may want to collect tomorrow. They're not limited to how the car was engineered and driven off the lot. They approach the manufacturing of the car in such a way that they will be able to collect new KPIs and new measurements, generate new KPIs from new measurements tomorrow using the existing infrastructure on the car. And number three, they use machine learning and artificial intelligence to analyze all the data they collect from these cars 24 hours a day, 7 days a week, to determine how to improve the consumer experience. And then they test it with a select market through software updates, and then they deploy it widely. That's why Tesla is awesome. Tesla is one of our clients. I don't know if anyone here has ever been in an automotive manufacturer before, somewhere who makes cars, but here in the United States, if you go from, say, a Toyota factory and then fly to a Tesla factory, if you're a Toyota employee and you fly to Tesla and you walk the plant floor in Fremont, or you walk the Giga in Nevada, you come out of that facility saying, we're out of a fucking job. Literally, that's the conclusion you come to. We're out of a job. Today, Tesla has fundamentally changed the way cars are manufactured globally forever. And at the same time, Tesla has single-handedly put all the major auto manufacturers out of business. And they know it. Ford knows they'll never make a car again. Ford knows a decade from now, no one's going to buy a Ford car. They're going to buy a Ford truck. They're not going to buy a Ford car. Toyota has already come to the conclusion they can't catch up. Okay. Toyota's already come to the conclusion they can't catch up. And therefore, Toyota has pivoted their attention to Toyota AI Ventures. And they will focus on supporting other manufacturers. Volkswagen, fortunately, started 5 years ahead of everyone else, and they're going to be fine, as will Mercedes-Benz and BMW. How did Tesla do that? Why is Tesla the only automotive manufacturer who did that? All the smart people who work at Toyota, all the smart people who work at Ford, all the highly, highly educated people. How was this guy from South Africa able to emigrate to the United States, create a tech company, start a car company that everyone said was going to fail, and then change the world? How was he able to do that? It's really simple. The answer is vision, Most importantly, vision. Number two, the value of data. So I don't know the roles of most of the people in the room. I'm assuming that we have managers, we have engineers, we have. Can you quickly give me the range of responsibilities of the people in the room?
Yeah, Walker, look, we're looking at managers, engineers, system integrators, executives. We're looking at research scientists. I don't know if that helps.
Okay, perfect. So let's start with the systems integrator. So let's talk about how the difference between an industry 3.0 and an industry 4.0 systems integrator for illustrative purposes. Okay. An industry 3.0, when I say industry 3.0, what I'm talking about is the period between 1970 and about 2000, where manufacturers automated industrial processes using PLCs. They converted relay logic into programmable logic. That was the third industrial revolution. That created data. It created data that no one was using. Lots and lots and lots of data. Right now, you have engineers and systems integrators in this room who know that if my customers or my employer are collecting data from the industrial processes that we automated, then they are only collecting a fraction of the data that's available. Okay, 5% or less. Okay, the engineers know that we're collecting a fraction of the data. Okay. Tesla collects everything, every single data point. I was in the room with Elon Musk for about 18 months as a contractor doing the Model S line. And one of the things that stood out to me there were a lot of things that stood out, but one of the things that really stood out to me about the leadership at Tesla was their focus on the value of data, data-driven decision-making, real-time data-driven decision-making, not sending co-ops out with clipboards and spreadsheets to collect the temperature off of this tank every 10 minutes, doing a time study over the next 4 hours. That would get you fired at Tesla if you made that request. That would get you terminated. One of the things that really stood out was the value of real-time data-driven decision-making. And there are people in this room who believe in real-time data-driven decision-making, and there are people in this room who are rolling their eyes. Okay. The people who believe in real-time data decision-driven making, real-time data-driven decision-making are the people who will have jobs in 10 years. And those who don't are going to be in completely different industries or looking back on this moment and saying what could have been. All right. Amazon. Everyone agrees that Amazon is amazing, right? Does anybody disagree that Amazon's not an amazing company? What they've achieved is not amazing? Why is Amazon so awesome? Is it because they put fulfillment centers all over the world within 10 miles of 99% of humanity, so that when somebody goes on their smartphone and orders something and they get the best price for it, they can deliver it to you within 48 hours or less? No, of course not. Is Amazon in South Africa?
Yes.
Okay.
Yes.
And
yes.
okay, great. And so right now, there are people in this room, everybody uses Amazon and they go and they order stuff from Amazon. I'll tell you a little story. If you buy a Kindle from Amazon, for example, say you go on and you buy a Kindle. I say, I want my Kindle and I want it in the next 48 hours. I want it delivered to my house in the next 48 hours. Here's what actually happens when you make that purchase. Okay. What happens is that Amazon looks at where you live. Okay. Amazon looks at where you live, and then Amazon determines whether they can manufacture that Kindle to order and get it to your door in 48 hours. That is, manufacture it after you've ordered it. So not pull it from inventory. Why do they do that? Because it's cheaper. And they operate on razor thin margins. And they do that in real time. They do that in 5 seconds or less. They determine whether or not they're going to be able to manufacture that to order and get it to your door within 48 hours. That's one thing Amazon does that's amazing. Okay? Because that puts them in the 3 standard deviations above the mean when it comes to manufacturers. Their ability to look at their operations instantaneously, determine whether logistically they can manufacture to order and ship it to you. And they can do that in 5 seconds. And that's one thing that makes Amazon amazing. So that's why they can get into the business of making Ring cameras and Echoes and all the stuff that Amazon actually manufactures that you guys buy. We all buy. But here's how Amazon has taken over the world. 60 days from now, somebody in this room is going, literally 60 days from now, someone in this room is going to make a purchase on Amazon. And it's going to, and 2 days later, 62 days from now, it's going to show up at their door. And Amazon already knows you're going to buy it. And they're already stocking it in the fulfillment center that it needs to be in order for you to get it in 48 hours. Think about that. You don't know you're going to buy it 60 days from now, but they do. They may not know that, Joe in the blue shirt, is going to buy it, but they know that someone in Joe's neighborhood is going to buy it. And when I say neighborhood, I mean 1 square mile. How do they do that? The answer is data. They collect data on every interaction a consumer has with their website, with their app, every single thing that you view, every product you look at, that every other person looks at. They know how long you stayed on the web page. They know how long you looked at picture number 3. They know how many reviews you read. And they use data to predict whether that's a purchase you're going to make. And then they use data to determine if that's a purchase you're going to make, when you're going to make it. So now if you work for a manufacturer, and I've demonstrated to you the power of digital data, the collection of digital data, and the power of real-time data-driven decision-making. And then in your head, you're comparing it to your current operations. Every person in the room should have come to the conclusion, whoa. Because manufacturers in general operate in the Stone Ages. Okay. One last thing before I get into, I'm going to go through a presentation I do for every manufacturer who is talking about Industry 4.0. They say, I see all this Industry 4.0 stuff, digital transformation, they're all buzzwords. What does it mean? I'm going to take you through the presentation and talk about what it actually means, but I want to touch on one additional point. Okay. And the importance of manufacturers creating a digital transformation strategy and getting started immediately. I'm going to walk you through what that process looks like. Okay. The employee of the future. Right now, manufacturers all over the world are having a great deal of difficulty recruiting and retaining the best talent on the planet. Okay. Here in the United States, it's next to impossible for a manufacturer to hire somebody out of college and get them to stay for 5 years. Next to impossible. Now, in South Africa, it's a little different, and your unemployment rate's really high for young people. But I suspect that for the 50% of young people who are employed, and especially the top 5% of that 50%, they are being highly selective about where they work. Okay. And the answer is, and the question has to be asked, why? Is it money? It's not money. We know that. Why is it that manufacturers are having such a great deal of difficulty recruiting and retaining millennials and Gen Zers? And the answer is that the employee of the future was born with a laptop or an iPad or a smartphone in their hands by the time they were 3. They've had access to all of human knowledge on their smartphone since they can remember. Digital transformation is about creating a smartphone for a smart factory. Industry 4.0 is about how businesses are made up of many plants that have smartphones for smart factories. And very few manufacturing facilities have a smartphone for a smart factory. So these young people who are used to solving their own problems, 99% of the time getting their answer from Google or YouTube, walk into a manufacturing facility. They look at the reality that most data and information is locked up in the silos of people in those facilities. Then they have to try and navigate the shark-infested political waters of those manufacturing facilities to unlock that knowledge and data and that potential. And they say, screw this, I'm out of here. They walk through those facilities and they say, I just went back in time 50 years. This is absurd, right? Okay, so I'm going to go through this presentation. Hopefully that has driven home the point here. My call to action here at the very end, the call to action here is going to be, what is it you're supposed to do the moment this presentation ends and you go back to the facilities you work at? Okay. I know that most of the people in this room are primed already. You guys already understand the value of data. You're already frustrated with the lack of tapping into the potential of that data in your organizations. I recognize that. What I hope to do with this presentation is lay a framework a little bit more to understand what's the bigger picture here. Is it really just digital dashboards and calculating OEE in real time and connecting the ERP system so we can retrieve the bill of materials for this SKU and, consume raw materials? Is it really all those things, or is it something bigger? And the answer is yes. It's all those things and something bigger. And that something bigger is the one thing most people are not thinking about. And that is, all businesses are going to plug into a supply chain ecosystem. I won't necessarily know all the potential distributors and suppliers I'm going to buy raw materials from. And I won't necessarily know every potential customer I'm going to sell to, no matter how specialized my industry is. Let me say this again. No matter how specialized my industry is, if I can't plug into a digital supply chain ecosystem where I'm going to be plugged into all the potential distributors and suppliers I could buy from, and I'm plugged into all the potential customers I could sell to, no matter how specialized I am, and I'm not going to be in business. I can't say that more firmly enough. I may be acquired, and I may plug into my new parent company's ecosystem, but I'm going to be plugging into an ecosystem. Okay. I'm going to go through this standard presentation that I normally do. Okay. So number one, what I want to talk about here as it relates to digital transformation is digital transformation is not continuous improvement. Okay. I'm going to try and draw this all together. It is not continuous improvement. Everyone here who's looking at the screen, you guys should be familiar with the technology S-curve, return on investment. Okay. When you deploy a lean or Six Sigma or a Kaizen methodology for continuous improvement in your manufacturing facility, you should all be familiar with this technology S-curve, right? That as we focus on use cases to improve our business, when we first start with continuous improvement, we're going to see very little ROI because we're just not very good at solving our problems initially in a way that is profitable. But as we get more comfortable with continuous improvement, which is this incremental gradual incremental fine tuning of our processes, we start to see higher and higher return on investment. We get much better at solving the use case. But over time, we start getting diminishing returns, and our ROI starting to flatten out. Okay. The industry 3.0 manufacturers, those people who have gone through the process of automating their manufacturing facilities, they've been in this stagnated flat for about a decade, or at least they should have been. What's most important to understand is that when we say, you know what, we're going to start the process of transforming to an industry 4.0 company. Okay. Most of them are taking that approach using old thinking, continuous improvement thinking. Digital transformation is not continuous improvement. It is groundbreaking innovation. There's in the Kaizen world, it's called kaikaku. It's a transformation of the business. It's a breakthrough. Old game, new rules. So we pause continuous improvement during our digital transformation initiation, and then we resume continuous improvement. Okay. So number one, most importantly for you quality engineers in here, you engineers, you managers who all believe in CI and are focused on continuous improvement. Maybe you're a black belt, Six Sigma black belt. Maybe you've been practicing Kaizen and tracking chokates for the last 2 decades. You're not going to embark on a digital transformation journey using that mindset. And if you do, you will fail 100% of the time. Okay. That's number one. Number two, why do you even care about digital transformation? Why should the shareholders invest in it? Why should engineers invest in it? Why should managers and executives invest in it? It's really simple. This is what every manufacturer wants to work towards. Now, from a operational standpoint, I'm talking about from an operational standpoint, what does a transformed organization look like? Well, the answer is they are simply a fully integrated business made up of digital factories. So what are the standards? Number one, everything and everyone is plugged into a network. If you work for an organization that limits network access to its employees, then you are working for a dying organization. If you work for an organization that doesn't allow you to go on YouTube or limits your access to getting information from the internet, you are working for a dying organization. Everything and everyone is plugged into the network. If you are looking at, if you're an engineer and you know of hardware that's on your plant floor right now that has data on that hardware that I could be collecting, and that smart thing is not even on the network yet, then you are working for a dying organization. And it really is that absolute. Number two, the layers of the business are integrated and operate based on data and information from all of the other layers in real time. What are the layers of the business? For those of you who are in ISA, the ISA world, that's going to be ISA 95 part 1. Okay. Level 0, level 1, level 2, level 3, level 4. I'll put it in layman's terms. In every manufacturer, you have 5 or 6 layers of the business. The bottom layer is the instrumentation. It's the plant floor. It's everything that's happening on the plant floor. The second layer is the HMI layer. It's the human machine interface. It's the digital interface to the smart things on the plant floor locally. If I can walk up to this machine and I can look at an HMI on it, that is the next level. The level above that is the supervisory control and data acquisition layer. It's when I can be in a central location and I can monitor digitally the entire manufacturing operation. The layer above that is the manufacturing execution layer. Okay, that is, how do I take a sales order in my business and transform it into a work order to complete manufacturing? The level above that is ERP, enterprise resource planning. That's when we transform into the IT side of the world. And the layer directly above that is cloud, where I'm doing big data analytics. The goal here is for you to create a fully integrated business made up of digital factories. And that does mean that the layers of the business need to be integrated and operate based on data and information from all of the other layers in real time. Number 3, stakeholders know the state of the business in real time, right at this moment. What's our most profitable SKU? What is our least profitable work center? Who is the least efficient employee? What are the top 10 work orders that are most in jeopardy of falling short of plan, et cetera, et cetera, et cetera? What's the OEE of this area? What is the OEE? What's the TEEP of the facility? Most importantly, if I am digitally calculating KPIs that will help me determine the state of the business right as it stands right now, then I can predict the future state of the business in real time. Okay, so Flow Software, the guys from Element 8 who are from South Africa, and Lenny and Graham, the guys from Flow, I've been working with their organization for several years now. And there's a platform that was created in South Africa called Flow. And I don't know who in the room is familiar with it. I'm not being paid to plug Flow. I love the platform. One of the things that sets Flow apart from all other software on the planet, I mean, and literally all other industrial software on the planet, is that the guys at Flow baked in the ability, if I know the current state of my business and I'm plotting using their platform and I can plot it, they automatically predict the future state over time. So I can chart here, this is what I've produced up to this moment based on my current state and all my past history. I can predict what I will likely produce by the end of the shift natively in their software without any additional engineering lift, just a configuration. Okay, the guys at Flow Software in South Africa, they get it, because the reason why is they couldn't have built that feature, they couldn't have integrated that feature into the platform with that if they didn't get it. If they didn't get this. Okay, we're going to leverage machine learning and artificial intelligence to collect and analyze data and information. Let me distill the value of machine learning and artificial intelligence right now. Okay, machine learning is really simple. Okay, the most popular machine learning algorithm in manufacturing is linear regression, and all that means is that if I've got a couple of data points, I can write an algorithm that'll say, for every value of X that I see right here, what are the potential outputs Y, outcomes Y? That's linear regression. If I see this value on the pressure sensor, what are all the potential likely outcomes for this other data point? That's all linear regression is. That's really easy stuff to do. If you're a data scientist in the room, they're going to tell you, basic machine learning is simple. Here's the real value of machine learning in manufacturing. It's assuming you're collecting high fidelity digital data on your entire business. Machine learning will be able to find patterns in that data you cannot see with the naked eye. Doesn't matter how smart you are. Doesn't matter how good you are with Excel. Doesn't matter how good you are with building a pivot table. Digital machine learning algorithms can find patterns in data that you can't see with the naked eye. And here are the implications for that. Okay. Right now, all of the use cases that you guys are using to solve problems in your business are hypotheses you came up with yourself. I believe that there is a correlation between this KPI and this bad outcome in our manufacturing environment. Okay, this KPI here on this machine and this failure on this component on this machine. The companies that are changing the world use machine learning to tell them to find which hypotheses to test. So you're in your first year of school. You're just a child, a naive child, if you believe that improving your business is a function of coming up with all the hypotheses to test and then improve upon. You are the Jedi Master. You are the Jedi Master if you are using machine learning to tell you which hypotheses to test. Okay? And you are the Sith Lord if you're using artificial intelligence to solve the problems that your machine learning algorithms come up with, spit out for you, okay? But in a nutshell, machine learning is going to predict future outcomes based on past patterns and current state, and artificial intelligence will recommend operational adjustments to improve future outcomes. Really good example here is going to be, why do we run certain products on certain machines at certain times? How do we decide what we're going to run and in which order? How are we going to decide which changeovers are going to happen and when? How are we going to decide which raw material vendor to use when we're creating which SKU? How do we do that stuff? How do we come to those conclusions? When we get to the logistics side, how do we decide which shipping vendor? How do we decide which external warehouse we're going to store in? How do we make those decisions? The answer is right now, we guess. We use tribal knowledge to try to come up with the optimal scenario. In a digital organization, scheduling is done by software, and it is modified by human beings. Let me say that again. If you work in a manufacturing facility right now where you have a planner, a scheduler, who is working themselves to death, they're the one person you're afraid is going to get hit by a bus. Okay? You are working in a dying organization. A digital transformation process is going to make their job much, much easier. Not any less important, but much, much easier. Okay. Where do human beings come in here? Human beings are the ones who decide whether or not to execute the recommendations that come from machine learning and AI. Okay. All right. The process. There is a tried and true way of digitally transforming an organization. And I'm going to close it out with supply chain 4.0 and the call to action. Right. Number one, I work for a manufacturer. What are the things that I have to do in order to be successful? Number one, you start with your digital strategy. So if I walked in the room, if I were in the room, I would be pointing people out right now and I would say, tell me what your organization's digital strategy is. The 3-sentence statement that says this is how we use data and information. That's what it is. Okay, a common one would be we use real-time data and information to drive decision-making quickly, universally, and uniformly. We use a unified namespace and built on MQTT Sparkplug B for our infrastructure. And then the third sentence would be the differentiator. Number one, in your digital transformation initiative, you must, every person in the organization must know what the digital strategy is. If you don't have a digital strategy, for everybody in the room, if you cannot recite a 3-sentence digital strategy to me, okay, that is where you start. You stop, you take 3 steps back, you call a meeting, and you ask the organization, what is our digital strategy? If they give you a 30-page PowerPoint, you say, this is not a digital strategy. This is excrement. A digital strategy is just like a mission statement. Number 2, approach every project as one part of a bigger whole. Engineers in the room, there is no such thing as a standalone project in a digitally transformed organization. In Industry 4.0, there is no such thing as a standalone project. What I build today is going to stand on the shoulders of what I built yesterday, the solution I developed, the screen I built, the PLC program I wrote, the instrumentation I installed. And what I do today is going to be the foundation upon which what I build tomorrow will stand. Number 3, this is one of the most difficult ones. Make no assumptions about how data will be consumed. And engineers in this room are guilty of this 24 hours a day, 7 days a week. You make assumptions when you're collecting data from a PLC is a really good example. When you collect data from a PLC, you make assumptions about how that piece of data is going to be consumed, how it's going to be visualized on a screen, how it's going to be historized, how it's going to be analyzed, how it's going to be reported upon. Stop doing that. And that works for a tiny use case, but that becomes a siloed solution that can't be reused anywhere else in the organization. So make no assumptions about how data will be consumed. Number 4, Treat all producers and consumers of data as a node in an ecosystem. It's a little more complex concept, but what it boils down to is this. Every piece of software, every human being, every smart thing in your organization needs to interoperate with every other smart thing, every other piece of software, every other human being through a common infrastructure. Okay, not linearly. That the layers of business I talked about earlier, the most common integration, the systems integrators here, the most common integration is PLC to HMI, PLC HMI to SCADA, PLC HMI and SCADA to MES. So generally the SCADA to MES layer. MES is generally the only thing that talks to the ERP. Every single smart thing needs to be able to talk to the ERP through a common infrastructure, not through a data bus, okay? Not through an API, but through a common infrastructure. And that common infrastructure generally is the unified namespace. If you guys want to learn more about the technical components I'm talking about, you can go, there's two places to go. You can go to iiot.university, which is a website that we run. It's a community we run that where we educate engineers and digital transformation professionals on how to use the techniques we employ for our clients. From there, you can join the Industry 4.0 Discord server. So we have a Discord server of about 3,000 like-minded people. Okay. If you want to learn more about the technical details. Okay. Or you can go to our YouTube channel. Just look up 4.0 Solutions on YouTube, and there's tons and tons of content there where I explain the technical details. Okay. Number 5, this is a technical component. Build a technology stack. Don't build a software or solution stack. I can't explain that right now. But what I'll say is don't go to Emerson or Rockwell or Siemens and say, digitally transform us. What you've done is you've bought Rockwell's solution and all of the limitations that comes with it. What you want to do is settle on technology for your organization, a technological infrastructure, write minimum technical requirements, then go to companies like Rockwell and say, do you meet these minimum technical requirements? So that thing, Factory Talk View, is going to plug into our ecosystem. We're going to be able to pull all the data from Factory Talk View, and Factory Talk View is going to be able to consume all the data from our ecosystem natively, plug and play, not without spending hundreds and hundreds of thousands of dollars just on building a software API. Okay. And number 6, most importantly, if there's anything you remember from this presentation, okay, you remember this: you must remain agile. This is where the light bulb should come on. Digital transformation is a process. Okay. It's a strategy. It's not a project. Okay. Digital transformation doesn't end. It's a function of your business. It's a function of how you approach your business. If you ask Elon Musk, when will the Tesla stop improving? The answer will be never. It's baked into the process. We're always going to be improving the car. So if I own my Tesla for 20 years, it's going to get better every month. What you want today, right now, the smart engineers and managers in this room right now have a long laundry list of wish items, items that they want to solve, problems they want to solve in their organization. And if they go to a meeting and they say, hey, these are the 5 problems we're going to solve, and they say, smart people, let's come up with how we're going to show, I want to build some digital dashboards, and I want to show these 6 KPIs to every operator on the plant floor. Okay. What you want today is a function of what you know today. And it's always been that. The difference is that this is a new paradigm. Digital transformation is about exponentially increasing the collective knowledge of your organization using real-time data and information. So let me say that again. Digital transformation is about exponentially increasing the collective knowledge of your organization by using real-time data and information. And if what you want today is a function of what you know today, and digital transformation is about exponentially increasing the collective knowledge of your organization, then it naturally follows that what you want is going to change exponentially as a function of this process. Systems integrators here. If it takes you 6 months to build an MES system for a plant, you're not going to be in business. You better be able to do an entire facility in 6 to 8 weeks. And we're talking 100 machines, totally different. And if you can't do that, you're not going to be doing MES systems because we can. If it costs you, if you're charging $5 million for an enterprise class MES system for, say, 40 plants, you're not going to be in business because we charge $500,000. The economy of industry has changed as a function of Industry 4.0. Okay. But you all must remain agile. You must go into digital transformation under the assumption that what I want is going to change every single day. Okay. Last 3 points, and then I'm going to pull it all together. Number one, digital transformation is a strategy. It is not a project. You should write that one in your notes. Number two, digital transformation is about transforming the way manufacturers operate their businesses by leveraging data they generate every day, but never or rarely consume in real time. Right now, you should all be terrified because you should be thinking about the hundreds of thousands of data points all over your facilities you don't even collect yet, let alone monitor, use, leverage in real time. You should be shaking. You should also be optimistic. Hey, we got a ton of potential here. And number three, most importantly, not everyone can be helped. I hate to break the news to you, but many of you are not going to be in business a decade from now. And I know you're shaking your head and you're like, oh, what does this guy know? I assure you, it's an empirical certainty. And if you join our community, you can see all the data-driven analysis as to how we can make those predictions accurately. We're not the only ones who are making them, by the way. But integrators, digital transformation professionals, engineers who work for manufacturers, they must invest their energy in the businesses they can help. So they got to start with finding people who admit they have a problem, manufacturers. Okay. I want to touch on one quick thing and then pull it all together. I talked about technology-driven approaches. Okay. I talked about nodes in an ecosystem. How am I supposed to approach digital transformation? There's a concept called the Unified Namespace, which is a term that we coined. And we've been talking about it. We've been doing our projects using this concept since about 2012. Okay, so at 4.0 Solutions, where we do architecture, we do digital transformation, maturity assessments for manufacturers, which basically teach them, hey, here's where you are, here's where you want to go, here's how you should get there, here's the technology you should use, the architecture, here's the project you should start with, here's the team you should build, here are the roles you need to add, you need to promote these people, you need to fire these couple of people over here. The core of our approach at 4.0 Solutions is the concept of the unified namespace, okay? And it's basically the ecosystem through which all the smart things in your organization interoperate, okay? Now, there's going to be lots of questions about, well, what if, smart thing A doesn't and smart thing B don't support the same technology? There are engineering tricks to make them using gateways so that they will, but all future things will use the same technology because you will write minimum technical requirements that you will give to your vendors. If you don't support this technology, we're not buying your stuff. Okay. So the unified namespace is a very important technical concept. Okay. It is the concept through which your organizations will plug into the supply chain of the future. So just like this ecosystem is made up of nodes inside your facility, you will also join an ecosystem where your facility is a node in a digital supply chain. Okay. All right. Let me get back to my presentation, and I know I've gone over and I want to pull it all together. How is Industry 4.0 changing manufacturing? Okay. And what should you do? Okay. If what you want to do is achieve the manufacturing holy grail, which you do, your executives want to, okay? Your shareholders want you to, and you want to. Your employees of the future want you to, okay? Then it follows that you will be able to plug into the supply chain of the future, okay? Where do you start? Okay? You're going to do two things. When you leave this session, You're going to go back to your manufacturers. You're going to talk to the highest person on the food chain. And you're going to ask them this question. What is our digital strategy? If they say, oh, there's some slide deck somewhere that lays it out, you say, no, that's not good enough. What is the digital strategy? And if they can't recite it to you, then what you say back to them is, we don't have a digital strategy and we need one. We needed one 5 years ago. We needed it yesterday. I would like to be part of the process that we go through to create a digital strategy. Number two, once you get authorization to create the digital strategy, which will help you work towards the manufacturing Holy Grail, which will make it possible for you to plug into the supply chain of the future, okay? The next thing you need to do is you need to say, what is our strategy? What architecture are we going to use to realize that strategy? And if you can't solve the problem yourself, you need to get help. In South Africa, we have a couple of different examples of organizations you can use. Element 8 is one of them. We're happy to help you as well. There are integrators, architects all over the world, part of our digital community. What I would strongly suggest you do is, once you are ready to embark on your digital strategy, your digital transformation initiative, join our Industry 4.0 community. Go to iiot.university, join the Industry 4.0 Discord server, watch the videos that we have on YouTube. All that stuff's free. There's paid stuff if you want to go through like formalized training, but there's a plethora of free information. 80% of it's free to help you on that journey. But when you get up and you walk out of here today, goal number one needs to be, by the beginning of next week, I want to know what our digital strategy is. And if we don't have one, I want to be the person who leads us to finding what it is. All right. All right. With that, are there any questions? Can I take questions? Is that okay? If there's any.
Walker, you are, as usual, are a thought leader provocateur. Sorry. And we're either all gasping with fear and trepidation at the future that we haven't contemplated. We are running out of time. Seriously, Walker, we were so generous to you. But I know in South Africa, mining is very strong, and that's the continuous manufacturing. And I know you alluded a lot to the discrete manufacturing. So we don't have time to go into that, but we have somebody and other people who I'm sure want to ask you questions around what about the continuous process manufacturing industry. And I certainly think we need another webinar with you in the new year where we are planning that, because we need to give you a whole lot of time here, and there's lots of questions.
Let me say this real quick. These strategies were developed in mining. So my first 5 years of my career was working in a salt mine, a half-mile underground, underneath one of the Finger Lakes in upstate New York for Cargill de-icing. These first concepts were implemented in the continuous mining process. And the reason why was because the advancement, a function of mining is how the infrastructure of the mine changes on a week by week basis. The extension of conveyors, the installation of stamblers, the upgrade, the maintenance of the mining equipment, the supporting any screening facilities underground or on surface. All of these philosophies were originally developed in mining between 2000 and 2005. That's actually where they cut their teeth. So yes, there are absolutely applications in continuous mining for these strategies.
Okay, Walker, we are going to have a session with the mining industry, bring you in there, because that's very exciting. So Walker, can we wrap up there? Is there any last thought you wanted to say? Because I don't want to give you too much time, because I know you'll take it.
No, this is what I want to say. Digital strategy, agility. You must remain agile and start with, what is our digital strategy?
Thanks, Walker. All right, I remembered Kaizen and Kaikaku. Step change, from continuous improvement to radical step change. I like that.
Thank you for
Thank
having me, everybody. Thank you.
Thank you, Walker. Thank you.